Okay, so what were we trying to do? I think I explained it the last time. LED what? So like, let's even go into the code itself. So first of all, we are doing digital write, and then digital write pin 18 high. It means that what that LED on pin 18 should go high, right? For how many seconds? 5 seconds, right? The next was what? Digital write LED pin 18 low. So it means that we are turning it off for what? 5 seconds, right? Then our next is we are printing something on the serial monitor, right? So what are we printing? From the top, you can see a number there. Unsigned int counter is equal to 0, right? So we start from 0. So it means that the counter here, for the first time, the counter will be what? Serial print into bracket counter comma 2. What does that mean? I think I explained it the last time, right? The last time I explained this. What does it mean? Serial print counter comma 2. Anybody? Master, I explained. I took my time to explain this. So I said we have some kind of we have number systems. I think you guys might have studied somewhere. We have binary numbers. We have decimal numbers, right? We have hexadecimal number. So if you take a number, if I give you a number like probably 7, you need to know the number in binary, in hexadecimal, in decimal, and stuff like that, right? So you have binary. So if I take the number 7, you know that this once I write something like this 7, it's in what? Decimal. Basics. Decimal. It's a decimal number. So if I want to convert this number to binary, you know what a binary number is? A binary number is just 1 or 0. It can be 1 or 0, right? So the numbers must be made up of ones and zeros. So I should be able to convert this number into binary. I think probably senior high school or something. You guys did something like this. How to convert a number from decimal to binary. You guys haven't done anything like that. Everybody did this, right? So if I want to convert this number to binary, I need to know the data weight. You know what data weight is? Data weight. Once you're programming, right, you have something called a data type. You guys know what a data type is? Data type. You have the int. You have probably in C++, whatever. You have int. You have float, right? Ha- Have you seen it before? Int 8 and stuff like that. Have you seen it before? Now, every data type has, because once you create something like a variable int a, right? Int a just means that you are creating space within your disk or your hard disk to store a number, right? If you use int, float, int 8, you are creating space within your hard disk to store a number. So, what is the size of that memory that you are creating? It's very important, right? So now, if you use something like int, what is the size of int? The size of int. Anybody? But but you guys have used this before, like int a, int b, a is equals to b plus c, that kind of stuff. Hmm? It doesn't matter. But you must know that every data type has a space in memory or amount of space it can use in memory, right? So if we take int, the int depends on the type of CPU you are using, whether you're using a 32-bit CPU or is it a 4-bit CPU. It depends, right? So, but mostly an int is a 32-bit. So it means that int can store a 32-bit value, right? So if we declare int a, it will create a 32-bit memory within your disk. You see how easy you see how easy that is. So now if you use float 2 might be 32. If you use int 8 just means it's 8-bit, right? So what does that mean? What does an 8-bit mean or a 32-bit mean? I think one of the questions you saw it there, right? If you use if I say I've created a 32-bit space, right? What does that mean? It means that okay, let's start with a simple one. If I create a a 4-bit space, if I create a data type that stores 4 bits, what does that mean? It means that I create a memory, something like this, right? And then we have memory location 0, 1, 2, 3. They are 4 bits, right? 1 bit here, 1 bit here, 1 bit here, 1 bit here. That means 4 bits. And each location can store 1 or a 0 because we are dealing with binary. Each location stores 1 or 0, 1 or 0, 1 or 0, right? Do you understand? So a 4-bit memory is arranged like this, and then each location 0, this means address 0 or location 0, address 1 or location 1, address 2 or location 2, address 3 or location 3. And each space can store a 1 or a 0 because it's binary, 1 or 0, 1 or 0, right? So what is the lowest number a 4-bit can store? Who knows? The lowest number a 4-bit can store. Anybody? Eh? The lowest number you can store. So listen carefully. As I said, each location can store 1 or 0. So if I want the lowest number, right, this location can store 1 or 0. So if I just take only this space, what is the lowest number you can store? What is the highest number you can store? 1. So you can store the highest number one location can store is 1. The highest number this location can store, the lowest number you can store is 0. So if I say I have a 4-bit memory, and what is the lowest number that memory can store? It means that you can store here 0, 0, 0, 0, right? You can store 0 in all the locations, and then that's the lowest number, right? So if I have 0, 0, 0, this is binary. 0, 0, 0 means a 0 in decimal. You see how easy it is? Now, if I say, what is the highest number this space can store? 1, 1, 1, 1. So it means that once I talk about the highest number, I must take each location. I know that each location can store a 0 or a 1. So this location, the highest number, only this location can store is 1, right? So the highest number the entire 4-bit can store is 1, 1, 1, 1. Right? And if you convert this 1, 1, 1, 1 is in binary. If you convert this 1, 1, 1 to decimal, what is it? What is the decimal value is? The decimal value of 1, 1, 1 is 15. Easy. Or you can say F in hexadecimal. Understood? Yes, sir. So this means that, what does this mean? It means that this space, a 4-bit memory location like this can store a number from 0, 1, 2, up to what? 15. It can go above 15. Once it goes to 16, there will be an overflow. So a 16 is 1, 0, 0, 0, 0. So you see that it has cut off this one because it has no space to store that last one. Understood? Yes, sir. Do you understand? Yes, sir. I think this is just you guys did digital logic or something somewhere. Digital electronics. Nah, I mean logic. Where you study number systems or something like that. No. Probably you guys have done it somewhere, but so now, so basically, this is now. So now, you have seen how I just did this, right? Now, to know the numbering systems are it's actually simple, but it depends on you. Now, if I say that if I say here, if I declare something like unsigned int counter is equal to 0. So as I said, the int creates some kind of space, right? And I said int is what? 32 bits, right? Right? So what is the lowest number the int can store? Just like how I did for just the 4 bits, right? I think one of the questions dealt with this. What is the lowest number the int value can store? What is the highest number? 1. So now, here, pay attention here. So if I say that, what is the once you know the number of bits, once you know the entire bit, right? If you want to know the highest number, there's a formula for it, right? The lowest number is just simple. It's always 0. Every time it's 0, right? The highest number this 4 bits can store has a formula. So it's 2 to the power the data type, right? Minus 1. Have you seen it? So if I have a 4-bit data type, so it means that I can store 4 bits. So it's 2 to the power what? 4 minus 1. So 2 to the power 4 is what? 16. 16 minus 1 is what? 15. Right? So you can just use this simple formula to get the highest number. Understood? So now if I have the int value, right, and I say that the lowest number you can store is 0, then what is the highest number? What is the formula for the highest number? 2 to the power what? 2 to the power 32 minus 1. So this is the highest number the int can store. It's one of the questions here. What? Yeah, it is always defined for you. Like if I want you to find it, I will define it for you. But anytime you see an int is always 32. Understood? Now, when I say the highest number, lowest number, then we just say 0 and 2 to the power 32. We might be wrong based on if the number is a signed number or an unsigned number. You guys know what that is? What is a signed number? If I say a number is signed, you guys must have studied it somewhere. The data start. So think about it. A signed number and unsigned number. Probably all this I'm saying might not be in the slides, but as I said, once I say it, I'll go and set questions on it. So just pay attention. It might not be in the. So now, the same way, the 4 bits, right? I said, let's use a simple example, the 4 bits. As I said, it does something like this. Numeric is in 0, 1, 2, 3, right? Now, I must know the numbers I'm dealing with. We have what is called signed numbers. And then we have what is called unsigned number. So here, once we look at the first line of the code is unsigned int counter is equals 0. So we have unsigned, right? So if I say a number is signed, what do I mean? Yeah, so the number can be positive or negative. If I say a number is unsigned, what does it mean? So if I say an unsigned number, I mean only positive numbers, right? So now if I say unsigned int, I'm talking about only positive integer numbers from 0 to the highest. It can't be a negative number. If I wrote here signed int, right, it means that negative and positive numbers, right? Right? So now, if I write something like this, if I have a number like this, 1001, and then I say, what is the decimal of this number? So if I just have a 4-bit number, 1001, what is the decimal? 513. Hey! The decimal volume. So now, so 0, probably 0 is 0000, right? 1 is what? 000. 2 is what? 0010. 3 is what? 0011. Okay, you have to learn this on your own. This is not a course for this, right? It's some basic kind of course you guys study before anything like that. And I think all of you have done it, but you might have forgotten. So just go and refresh yourself on stuff like this. But if I give you a number like this, right? 1000, like 10. The number 10 is 1000, right? In binary. So the number 11 is what? 1001. So 10, then this one is, right? You understand? So 111, 1001, you'll be tempted to say what? 11, right? Now, it depends. I must know the sign, whether this number is signed or unsigned. So if I give you a value like this, 1001, and I say what is the number, right? You can never determine what number it is or what the value of the number is unless I know whether it's signed or unsigned, right? If I talk about a signed number, right, right, it means that I have negative numbers inside there, and I have what? Positive numbers. That is signed. Now, how do you identify whether a number is positive or negative? That's a big issue, right? Now, in terms of computing, right, you if a number is signed, you always use the last bit. We call it the MSB. So if I say a 4-bit number, the last bit of that number is called the most significant bit. And then the lowest bit, this one, is what is called the least significant bit. Understood? So if I say a number is signed, once I mention that the number is signed, it means that I can identify if the number is negative or positive by using the last bit, the MSB. Understood? If the MSB is 1, it means the number is negative. It's a negative number. If the MSB is 0, it means the number is positive. So it means that if I want the range, right, if I have a 4-bit number like this, and I say that the number is signed, right, it means that the MSB is out of the number because that particular bit here is used to identify the number. Understood? So it means that the rest of it is the actual number. So if I have something like 1001 and I say it's signed, so it means that I have to forget about this MSB and use only these 3 bits to identify the number. So this is negative 1. 001 is what? 1. So this is negative 1. Understood? So now I need to know the lowest number this 4-bit signed number can store, and then the highest number. Who can tell me the highest number this 4-bit signed number can store? The highest number. You guys must have studied this thing somewhere, but I'm sure 10 years you have seen it somewhere. Right, so as I said, now if I want to know the highest number of a signed number, right, I have to remove the MSB. The MSB is not part. Now I'm left with only what? 3 bits. This one, right? So it means that the lowest number will be 0. Right? Always the lowest number will be 0 minus the sign. Right? Because I'm using only 3 bits. Now the highest number will be what? I have to remove the sign. I don't have to care about the sign. The highest number will be 111. Right? So once I remove this one, 111 is 7. Right? So the highest number a signed number can store, a 4-bit signed number can store is 7. So it means that the formula, how will the formula be like? I've removed 1 bit from the entire thing, right? So it will be 2 to the power, the data type, right? Minus 1, the data type minus 1, then minus 1. Understood? So here it will be 2 to the power 4. 4 is the data type, right? Minus 1, then minus 1. So 2 to the power 4 minus 1 is what? 8. 2 to the power, so it will be 2 to the power 3 minus 1. So 8 minus 1 is what? 7. So that's the highest number a signed number can store. So you see that at first, if I say the number is unsigned, I can use the entire thing to find the highest number. So at first it was 1111. 111 was what? 15, right? So it means that the highest number of a signed number of an unsigned number is the whole thing. So it will be for this 4-bit is 15. The highest number, if I say is signed, it will be 7. So it means that it has cut the range by half. Understood? 15 and 7. You see that it has cut the range by half. Understood? I mean, there's not a course for this, so you guys can go and study it You guys must stay somewhere. Then just refresh yourself there. So now, if I say unsigned int, right? What is the highest number? Huh? Unsigned int counter. Unsigned int. What is it? What is int? I said, what is the data type of int? 32. So what is the highest number? Hmm? What is the highest number an unsigned int can store? 2 to the power what? Uh-huh. Minus 1 on the top, and then minus 1. So this was part of the questions, right? Easy. Easy. So now here, so for this code, right? For this Arduino sketch, as I said, code or sketch. In Arduino, we use sketches. So this is an Arduino sketch, right? So I turn the LED on for the delay into bracket 1,000 means, if 5,000 means 5 seconds. I already explained this. And then I turn it low. I off it for 5 seconds. Then I come and print the counter, right? Hmm? Master, I just gave the formula for the unsigned tool. So go and watch the video. Shall I continue? So for this code, right, I said the first print, serial dot print will print the counter value, but once I put comma 2 to there, it's printing the binary value, right? Then serial, yeah. Yeah, so in case you are printing anything in serial dot print, right, within it, right, you can print a string. So if I want to print a string, you know what a string is? Like ABCD, like the boy is going to, if I want to print the boy is going to school within the serial dot print, I must put quotes here and quotes here. Then I can print the string. Right? If I want to print a number, I might just put serial dot print then the number. Or you see that here I've declared the number on top. The counter is equal to 0, some kind of constant, right? So if I want to print it, I'll just do serial dot print counter. Now, if I don't bring comma 2, the default value will be a decimal number. If I don't bring anything, comma, anything, so it means that I'm printing a decimal number. But if I want to print the binary number, I must bring comma 2, and then it will print the binary number. Simple, right? If I want to print the hexadecimal value, right? I bring 16 hexadecimal, and then it will print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you know that hexadecimal for 10 changes to A, B, C, D, E, F. Then it starts over again. Understood? So this code, the first line will print the counter value, but in binary. The second code, serial.print, quote, dash. It means that I'm just printing a space, right? A space, right? Then the next one, serial.print. On the same line, it will print the hexadecimal value of the counter. And then another space. And then it will print the counter value. So if I bring serial.print counter, just the counter, I said it prints the decimal value, right? Then after that, I come and increment the counter. You see, counter plus plus. You guys might have seen it in C++. Counter plus plus just means counter is equal to counter plus 1. So if the counter was 0, right, it will have to do 0 plus 1 and then give it to counter. So the next counter value will be 1, right? If it's 1, the next counter value will be 2. So you have just increment the counter. And then we go back. As a void loop just means that we are looping over the code. We will loop and loop and loop and loop. So once we increment the counter, we will come back again and come and do digital write. So we put the LED on, LED off for 5 seconds, whatever, and then go through the whole entire code again. Right? Understood? So I don't think I need to compile this code. You guys, I compiled it the last time. So should I move on? So this is our next code. Like, so let me just give you some small time to just digest the coding so then just explain it to me, right? So let's move these chairs. What is this code doing? Just just 2 minutes for you to think about it. Master, why are you looking at me? The code is over here. Just 2 minutes. Just try. Just try and think small. Pardon? And I'm just giving you 2 minutes, so just think about it. After that, I'll ask you. But I've made all these codes are in the slide, so you guys could have run them before coming. Who don't know anything? Who? Uh, why? Are you in their mind? Uh, but you know, right? You, so, as I said, just try it. Just think about it. Don't, don't just say I don't know. Then just sit down there. So, so let's go. Hurry up, hurry up. Hmm? To you, is it sensible? No, but at least he has tried, right? So it doesn't matter whether it's close or not, but at least he has tried. So, okay, what is it? No, no, this is just code. Yes, just code you have seen. At least, you see, so this is you know that we have high level languages, right? We have low level language, right? I program in very low level language, so that one you must think like the machine. So you are looking at ones and zeros and figuring it out. That is difficult. That one I understand, but this is close to English language, just like serial dot begin. You know what serial is in English. You know what begin is in English. You know what RND one, right? Then you know it's equal to random. So you can, without even knowing what the entire thing is, but using your English language, like, right, you can actually guess it. That's how easy a high level language like the Arduino sketches, right? But if I give you some low level language in ones and zeros, you can't actually figure it out. But this one, you can actually know what it's doing. You can figure it out. Understood? So just open your mind. But whatever. But the first, the first, the first line, constant byte LED pin is equals to 4, right? I'm just declaring a constant, right? Constant. As I said, this is as close to human language as you can. So const means constant, right? Byte is what? 8 bits, a byte. So if I say 4 bits, so 4 bit, 5 bits. So if I say a byte just means 8 bits, right? LED pin is equals to 4. So it means that I have an LED pin and then I'm just giving it the number 4, which is a constant. Is it like that? Right? And I have unsigned long on counter. So it means that I'll have something, an on counter and an off counter. The on counter counts the number of times the LED is on. The off counter counts the number of times the LED is off. Easy, right? Now I come to my setup. I said the setup is done only once in the Arduino sketch. I've already explained this. It's done only once. And then I said the serial dot begin means that I have my Arduino board. Right? Where's my Arduino board set? We are using this board. Those of you who were not here, we are using this board, right? This is Arduino Nano Science board. So the serial dot begin here means that I want to talk to the board. But how do I talk to the board? So the board is always connected. The board is always connected to the PC through the USB cable, right? Right. So how do I send data or receive data from the board and to the board? Through the PC, right? I said Arduino's, the good thing about Arduino is that it consists of libraries. Once you know the kind of library to use, everything becomes easy for you, right? The serial library helps you to communicate or send data to the Arduino from your PC, from your serial monitor on the Arduino IDE, right? It helps you to send data from your PC to your board, and then from your board to the PC. Easy, right? And then I made mention of the fact that once you use here to begin into bracket 9600, now in order for it to send data to the board or receive data, they must agree on something, right? What must they agree on? The speed of the data. How fast am I transmitting the data? If they don't agree on the speed, it means that the data will be received wrongly, right? You guys are doing telecom, right? You guys might know you guys might know stuff like this. So you have to define the baud rate. The 9600 just means the baud rate. How fast I'm sending the data from the PC to the board and vice versa. 9600, yes, it's just a constant, right? Then I come into my loop, right? I declare two random numbers. Round one is equals to random and into bracket some number. Once in programming, once we see 0x here, that means that the number is hexadecimal. If I don't put anything there, it means that the number is decimal. But once I put 0x or right, then anything, it means that that number is hexadecimal. So I declare, so I said everything deals here, we are dealing with libraries. So the random, once you see anything in this yellow thing, right, it's a library. So we are calling that library, right? So the random library takes a maximum value or a minimum and a maximum value. The random means what? The random library, what does it do? This is just English. So what does random means? So if I put a number there, a random and then a number, what does it mean? Masa. Why? So if I put random and I put a number there, what does it mean? Just by your own senses. Ava. I mean, I mean, it's just. it- sorry. I mean, it's just English, right? I mean, so it's a library, random. It's just a library. So that's something. So if I put the the random library takes a maximum number. It takes a maximum number, or I can have something like random, and then it takes a minimum, comma maximum. So if I put only one number within it, right, it means that it generates a random number, right? But the number can go above the maximum number. So if I put random 0x7FFF, it means that it will always, anytime it loops, it will generate any random number at all. But that number can go above 7FFF. And that's what the second line also does what? The same thing, random. But for this time, I've given it two values, minus 100 and then comma 100. So it means that it will generate, anytime it loops, it generates a number. But it can't go below minus 100 and then it can go above. So it always generates a number between minus 100 and what? Easy, right? So you see how once you go through the code, just go line by line, then you understand. It's just like English, right? English language, right? And then my next one is what? Serial.print random one. What does this mean? English, just by your own. What does it do? It prints random the number it has generated. So it generates two random numbers. One is random one and random two, right? And then the first line, serial.print random one will print that the first random number. Serial.print then it just prints a space. Yeah, serial.print here prints a space. So random number one space. Serial.print run two, right? Run two. It does what? It prints the second random number. Then another space. Easy, right? Then we go into the if statement, right? So if random number one, so you see that here, just like English, right? Just look at the code. Random number one is what? What is their sign? Less than. So you see that it's just English. Unless you don't want to think some more. So just little thinking, right? You just know that it's just like you're just reading some book, right? Random number one. So it means that if random number one, the generator random number one is less than something. It's less than what? This is the this is the highest number. 7 is what is this? What is that sign over there? Okay. Okay, so here this one just means less than. This means greater than, right? Greater than or equal to. But how many of you have coded in C before? C program. Hurry up. Just see anybody. I just want to know who has done C before. C programming. All of you have done it, right? No, but to see that yeah, is it what? So if it's equal to what is this one to? Okay. So if you see something like that, so we have just like in maths, we have operators, right? We have the less than operator, we have greater than operator, we have equal to, we have plus, minus, division. All of them are within this code. We also have operators like shift, shift left, shift right, rotate, right? Rotate left, rotate right. So if I'm shifting a number, right, left or right, you must know what it does, right? So if I have something like this, a 4-bit number like this, if over here is 1000, and then I use an operator like this, it means that I'm shifting the number, right shift. Simple, right? If I use an operator like this, it means what? Left shift. So if I shift this number 100 1000. I shift it to the what left, right or left? Right by 1. What does the number become? Huh? I'm here, right? I'm shifting this number here. Pay attention because it's very important, right? If I'm shifting it here, what does it mean? So what becomes the number? So the same way, I must know the bit width is 4 bits, right? So I'm taking this entire number, I'm shifting it to the left, to my right, probably by 1. What does that mean? So it means that I'm cutting this number off. The last one, I remove this number, and then I bring this one here, this one here, this one over here, and then I put a 0 here. Easy, right? So it becomes 0100. Hi, wow. So you see how easy that is? I'm just shifting. So the shift just means that I remove the last one, and then I said the last one is called the LSB, least significant bit. So I remove it, and then I push all the rest of the numbers, and then I put a 0 in front. So here, so this same number, if I say shift by 2, what does it become? Shift by 2. Huh? 0. Easy, right? Right? Yeah. Yeah, of course. The same way. You move the you. So it means that in shift left, you remove the MSB. So if I say shift left by 1, I remove the last this one and push the rest, and then put a 0 at the end, and put a 0 at the end. Right? If I say by 2, I remove the first 2, shift these 2, and put 2 zeros at the end. Easy.
So it means that whenever I shift, it's represented by 0.
You put a 0 at the end or at the beginning based on whether it's left shift or right shift. Understood? Now, so here, what does this mean? 0, 7, left shift 1. It means that I shift by 1, right? Now, it's when you look through somebody's code, right? Uh, the code we write, right, will determine how efficient it is. And then if I say efficient, it means that will it run for longer or will it run for shorter? So if you look at somebody like 2 people can write the same code to execute the same thing, but one code will take a shorter time, one code will take a longer time. It depends on how you code and how good you are in the coding, right? So that's why we have bad coders. Like the thing works, of course, but it's consuming a lot of resources like power and stuff like that, right? And then we have very good coding, like it does the same thing as the bad code does, but it does it efficiently. It depends on how you use the operators, right? So now, if we talk about multiplication and division, right? You have addition, subtraction, you have shift left, shift right, and stuff like that. These operations are easy to do, right? They don't consume a lot of resources. So once I say add 2 numbers in a program, you must think that we are using some kind of algorithm to do addition, right? So that algorithm is using to do addition is really easy. Than the algorithm, you know that to multiply numbers, the algorithm is actually longer than to add numbers, right? Everybody knows that. Multiply number, add number. The algorithms are different, right? Division, very complex, very complex algorithm to do division. Even though you can do it in your mind just like that, but the computer does it. It says it to be very complex because it is actually complex. Division, right, and multiplication, very complex. And then because it's complex, it uses a lot of hardware resources and it uses a lot of power, and then it takes time, right? So if somebody says that divide a number uh, by 1, right, by 2. If I have the number 4, right, decimal 4, let's say a 4-bit. 4 is what? In binary. 4-bit. This is how 4 looks like. 0, 1, 0, 0, right? That is a 4-bit number, right? Now, if I want to divide this one by 2, right? What would be the answer? 2, right? Now, if I use the operator, the division operator in my code, it will take some time. It will take a long time, and then it consumes resources. But a very good coder knows that if I divide 4 by 2, I get 2. And then it's the same as if I shift the number to the left by 1. So just pay attention here. You see 0, 1, 0, 0, right? If I shift this number by 1, what happens? Shift left by 1. All right, whatever. So shift here. It depends on where I'm facing. That's all right. So in case I'm shifting, in case I'm using this operator by 1, what happens? Huh? So you see that the number becomes 0, 0, 1, 0. 0, 0, 1, 0 is what? 2. Pay attention, understood? Simple logic. So it means that anytime I'm dividing a number by 2, uh, I can decide not to use the division operation. I can decide to just shift the number by 1 to my what? Right by 1. And then it has divided the number. If you doubt it, let's take 8. So 8 is 1, 0, 0, 0. Right? Now if I take 1, 0, 0, 0, and then, okay, 8 divided by 2 is what? 4, right? Right? Now, if I shift this 1, 0, 0, 0 to my right by 1, what happens? It becomes 0, 1, 0, 0. 0, 1, 0, 0, y is what? 4. I've divided the number. I've effectively divided the number without doing much. Easy, right? So here, that's exactly what I'm doing here. I'm taking this number and I'm dividing by 2. Because I've shifted left by 1, or divided by 2, right? So if the number is less than 7 FFF divided by 2, what do I do? So now let's enter this if here. Let's enter into this code. The if statement. If the number is less than 7 FFF divided by 2, means that I've divided the number by 2, right? But if it's less than that number, what do I do?
On the
On the LED, right?
print the
So I on the LED pin. So you see that the LED pin is 4. So LED pin 4. I on it, and then I print serial.print. So I said, in case I want to print a string is just character. So I print LED on, and then that sign, and then I do on counter plus plus. On counter plus plus means what? I explained it in the last one. So if I see on counter plus plus, I increment the on counter by 1. So this is at first the on counter, and then the off counter one. It always starts from 0. So I increment it by 1. So it will be 1. Right? Else, so it means that if the random number 1 is less than that, that's when this code will execute. So anytime you see an if else statement, if this is less than this is when this code will execute. Else, it means that if it is not less than, it means that if it is greater than that number divided by 2, right? What does it do? It off the LED, and then it prints LED off, and then off counter increments, off counter plus 1. Easy, right? Then the next one is I come and print the on counter, serial.print on counter, then space serial.print off counter. Then I delay by 4 seconds, and then I loop over the code again. So do we understand? But you tried at least. Nice job. So do you understand? So probably for those who were not here the last time, let me try and run it so that you guys see how the Arduino code runs. So this is the code, and then I think I walked you through the last time how to run the Arduino code. But for those who are not here, right, we will just go through. So this is the Arduino ID. That's where we are going to write our codes and upload the codes to this our board, right? I believe that if I say that we should go through the how to go through how it's done, even though I've taught some of you already, you guys will say, ah, nah, right? So what do I do first? I connect my board, right? I connect my board to, and then once this one powers on, if I see the green light here, it means that it has received some power, and then I can continue with what I'm doing, right? So from there, what do I do? Huh? Must hurry up, hurry up, hurry up, hurry up. Ah, you guys, so from there, what do I do? Okay, so from there, what do I do? So you select the board. So once you connect it, right? Once you come here, the board will show. If it doesn't show, you just go to it, and then it will show you the COM port it is connected to the port of the PC, right? So here it's connected to COM port 14. So you just select it, right? Then after that, you do what? I click on this one to compile the code. What does what does what does it mean by what do I mean by to compile the code? Oh, nah, she was here the first lecture, right? Or you guys were and you were here.
She was the one repeating the compile. She was the one. You know the guy. You remember that one, but I don't remember what you took.
So I compile the code, and then as I said, once it's compiled on, this is it will give me some information here about my code. If there's an error, it will show in this console, right? If there's no error, it will just show that global variables use this, and then it gives me the RAM size and then the flash size of my code, right? Then after that, what do I do? Right? And then that's this one. And so now I've compiled my code. I've seen that there's nothing wrong with the code. So I just have to upload the code onto the board, and then the upload is just this board. This one here. Once I click it, it will begin to upload the code onto the board. Right? And then once I open the serial monitor, so everything, the serial.print will print anything I'm doing on a serial monitor. So I have to open it. I showed you how to open the last time. You come to tools and click on serial monitor, and then it will open this one for you. So it's still uploading. So once it's done, it will say done uploading, and then it will give you the number of seconds it took to upload, right? So then I click on the serial monitor, and then you see what it's doing there. So it prints, first of all, it prints the random number one. Have you seen it? Then it prints random number two. Then it does LED on or off. So now the LED was pin what? 4. Where is pin 4 on this board? The fourth pin. So how do I know the pin numbers on? How do I know which pin is pin 4? How will I know? So you see this diagram, right? I showed you the last time. And then the pins are numbers. So if I say digital pin 4, what am I talking about? This one right here. Have you seen it? And then this 4, right? So it's, let's say from the bottom, it's what? 1, 1, 2, 3, 4, 5, 6. So pin 4 is on the 7th one. So if I want to see whether the LED is blinking or not, I have to connect an LED to it, right? And then, so I took the effort to bring an LED. For those of you who have not seen an LED before, this is how it looks like. Everybody have seen one before, right? So, and then for the LED, you can identify the positive side and then the negative side by how long the pin is. The pin is. So the longer side is what? Hey. The longer side is the positive side, right? So I connect the positive side. I connect the positive side, and then I connect the what? Then I connect one of the pins to the negative side, right? Then I connect the positive pin to what? On the board. Where do I connect it? Masa. So I said pin 4, right? So the 7th pin on this board, I connect the negative side, the positive side to the pin 4 here. The pin 4, it was what? 1, 2, 3, 4, 5, 6. So the 7th pin, right? And then I connect the negative to what? Huh? I have to connect the before it works. I have to connect it to something. To what? 5 volts. To 5 volts. You are just trying to create a bomb like that. Too. So I need to connect one pin to a voltage source. The other pin to what? The output source is the voltage source because I'm supplying it voltage. The output source is the pin 4. This just so I have to connect this pin somewhere. If not, it won't work. So just look at the pin mapping. I connect it to the ground. Simple. So it means that if you have a house, then you connect. Right, okay, it doesn't matter. But you see that the ground is here. The GND is the ground. So I connect one pin to the source, and then the ground is from the left side is the second pin. So I just connect this one to the second pin. Right? And then I have to come and check the serial console. So right now it's off, right? You see that it's off. Look at it. Off, right? So the LED is off. Off. You see that it's printing off. On. Have you seen that it's on? So it prints on here. So that's just how this entire code is doing. Basics, right? Understood? Understood? You understand? You understand? This simple demonstration. Like from where? Like what? Don't you understand?
That question, yeah.
She understands.
You know, ask that question.
Please, do you guys understand?
Yeah, yeah.
Do you understand?
Say she should watch the
Are
video.
you? Are you? Is it the code you don't understand, or the connections ideas you don't understand,
Connections.
or the whole show? The connections. What? So as I said, the pins.
We have a question on the connection.
Huh?
We have a question on the connection.
Okay.
Said in there's another ground too.
Yeah, it doesn't matter. You can connect any of them.
It will work.
Yeah, it will work. Once it's ground. Why are you still? Please, if you don't understand, ask now. Yes. So why don't you understand?
After compiling, he said we do
After compiling. So we compile the code here. So we click on this one to compile the code. Right? So after you compile, what is our aim? What do we want to do? We will have to download or upload the code from the PC to the board. You don't even need to write anything.
What did she write there? That's why I understand. What did she understand?
Okay. So
So you compile the code to see whether there are some errors, right? It finishes compiling and then you upload the code. So now you send the binary file of the code to the board by just uploading here. So you just click on this one and then it will upload the code for you onto the board. Anything else?
what next? The output.
What? So after it has uploaded, so what were we trying to do? We said that we are setting, we are generating random number 1 and 2, and then we are taking random number 1. If random number 1 is less than some value, as I said, this value here, right? If that random number is less than that value, it should put on the LED, and then it will print LED on. As you can see in the code, LED on here, right? Then it do on counter plus plus. It will increment some counter. On counter, the counter is called on counter. Else, first of all, you laughing. So else, if that number is not less than that, so it means that if the number is greater than, right? It means that we off the LED. This LED, we off the LED, and then we print LED off, and then we increment the off counter. And then after that, we just come and print here the on counter, and then we print the off counter. We delay by 5 seconds, and then we loop all over again. And then here we can see the code working here. Have I uploaded it? So it will working. So it will print. For instance, here it will print a random number, the first random number. That random number should not be greater than 7FFFF, right? Then it will print the second random number between negative 100 and then 200. And then it will print LED on based on if this number is less than the 7FFF divided by 2 or not. And then it will print the off counter, on counter, and then that's basically it. Do we understand? Do you understand? Shall I continue?
Yeah, yeah.
Okay, let's just do this one, then go away. So this is a very simple code. So just take 1 minute to and let's see what it does. The first one, example 3, just this simple, just about what 5, 6 lines of code. What does it do? That's just the last one, and then we go away. What does the code do? What? Just this code, like 7 lines of code. Just English again. Just go through step by step. Just read one line at a time, and then you don't even think at all. And so quickly, right there, I said that the serial does what? What does the first line of code serial? What is it doing? I want to communicate. I want to send some data, or I want to form some kind of communication between my PC and then the Arduino board. I want to send data to and from to the Arduino board and from the Arduino board through the PC or whatever. Understood? So this is what we have. This is my this is my computer, right? This is my board, my MCU, right? The computer has a pin, like the USB port is a two-way communication, right? It has a pin called TX. TX means for transmitter. You guys, telecom engineers. So you have the TX, right? The TX means that I can transmit a value or a number through that pin, right, to the board. And then once it gets to the board should be able to receive it. So here it will be what? RX, the receiver of the board. And then I can also transmit from the board, TX, to the computer, right? The computer also receives it, RX, right? Now, uh, what actually happens is that once I'm transmitting a value, right, the value will be stored in what is called the buffer, right? I transmit a value, it will go and store that value in the buffer of the MCU. Probably I'm transmitting a value from here to here, from the computer to the MCU. It will go and store it in a buffer. And then the buffer is just a space created to store some value from the PC, right? The buffer is 64 bytes. You know what that means? 64 bytes. It can store only 64 bytes. So if the value I'm storing is above 64 bytes, then I'll have an issue. But if it's below 64 bytes, then I'm fine, right? So it will go and store this value here in the buffer. And then if I want to read that value stored in the buffer of the MCU, right, I have to first of all do what? Check if there's any value available. That's why I said it's just English language, right? So if I come into the loop here, if serial.available, so the serial.available is a library that has the serial is a library that has a function called available. The available checks to see if there is any value in the buffer, right? So if it does, serial.available is greater than 0. So if there's a value, that value there, it will count the number of values and give you a number. If there's no value, it gives a 0. So if serial.available is greater than 0, it means that there's a number there, right? Then do what? Serial.read, another, again, English. So serial is a library, read is a function within the library, serial, that will read the value from here, from the buffer, and gives it to a variable called what? Var. So you see byte var is equal to serial.read. So it will read the value in the buffer and give it to var. Simple, right? Then what do you do? Serial.print receive. So it prints the text received. Then serial.print var. It prints the value you read from the buffer. Simple. Are we are we clear?
Why is this buffer?
Yeah, the buffer is on the MCU. This one here. So it's trying to read a value that was sent to the MCU. That's what this code is doing. So it means that, so let me see. So what that means is that so I'm just compiling the code and then to show you how it works. So I compile the code. Is it done? Yeah, so it's done. So I upload the code. So I upload the code also. Then I open the serial monitor. So it's done uploading, right? So I open the serial monitor and then what do? I type a number here. So this is the serial monitor and then I can type any number and then it will first of all send this number to this MCU and then it will read from the buffer of this MCU. That's all it's doing and then print it here. So if I send, so now pay attention. Not range from 0 to 64. Then I said this buffer can store up to 64 bytes. So 64 times 8 bits. Right, so now, now pay attention here. This serial will read has some kind of limitations, right? So if I type one here, if I type one, right, what do you think it will print? So if I type one and then I enter, what value has it printed? Received what? 49. If I type two, what value will it print? If I type three, what value will it print? 51. So these ones are characters. So it's printing the ASCII value of the number. Do you know what ASCII values are? We can find out. So the ASCII value of 1 is 49. So the serial dot read prints ASCII values of the numbers I'm typing, right? If I don't want, in case I want to print the integer values, just integers, so from 0 to 9, I have to use serial dot pass or something. Right? It is also in the example, right? So as homework or homework. So as homework, just form groups of like 4, right? And then I think I posted it. I posted it in the group already. So I said, what I want you to do is that with that same idea, what I just want you to do is this: a very simple. Where did I put it? So very simple. So I have this is your first lab. So I have this the serial that reads from here, right? Reads you send it a value and it reads from the buffer here, right? This code does that, and then here, as I said, we are using pass int. So if I enter a number, it gives me the integer value of the number. Simple as that. It gives me the integer value of the number, right? So what I want you to do is I want you to edit this code, and then I want you to get a number between 1 and 9. So I'll enter 1 in the in the serial monitor. If I enter 1, so it gets that number 1, or from 1 to 9, right? It gets that number 1, and then it sends the number to the board. Very easy. It will send that number to the board, and then it will blink the LED, right, for the number of seconds of that number. So if I enter number 1, right, it will turn on the LED for 1 second, then goes off. If I enter number 9, it will turn on the LED for 9 seconds and put it off. That is what I want you guys to do. So form groups of 4, 4, 4, and then I'll take it next week. You just come and explain the code to me.
So we have groups, but it's more than 4 members.
Hmm?
It's more than 4 members.
You have what?
We already have that
But
trouble.
it's more than 4 members.
It's how many?
5 members.
Oh, okay. So take that group and then add the guy from.
What?
So and then ask add the typewriter guy too. So
Yeah, okay.
one group must work with him.
No problem.
So you see how easy. So you can test it on any Arduino board you want. If you have an Arduino board, test it. Or if you want to risk it, you can come and test it. If it doesn't work, then you get 0. If it works, then.
Yes, sir. Why are you calling me? We're in class.